Alright guys, I'm going to show you how to graph a quadratic function by using intercepts, vertex, axis of symmetry. Now we don't have all the tools we need yet, but we do have enough that we can do this fairly quickly. As we learn a little bit more, we'll learn some other little shortcuts and things. But let's start with what we've got. Okay, so here we go. Let's go ahead and start with the y-intercept. Okay, so the y-intercept we can find by setting x equal to 0. This is the same as back when we did linear graphs. So we're going to go y equals 0 squared minus 6 times 0 plus 8. Now if you work that out, hopefully you get that y equals 8. So I'm going to put down my y-intercept there at 8. Now the name of this point is 0, 8. The x value is 0, as we stated. The y value is 8. All right, so now let's go ahead. Let's do the x-intercepts. So the x-intercepts, of course, happen when y equals 0. This again is exactly the same as when we did linear graphs, except a quadratic equation gets dealt with a little bit differently. So we go 0 equals x and x, and let's go minus 4 and minus 2. All right, so that means that x minus 4 equals 0, or x minus 2 equals 0. So x equals 4 or x equals 2. These are both x-intercepts, so we're going to put both of those down. I've got 4 and I've got 2. So this one is 4, 0, and this one is 2, 0. So now we already kind of get a good idea of what this maybe looks like. Looks like we're up here, we come down. Now we know for quadratics it's going to curve and come back and then go back up. What we need to recognize next then is where is the axis of symmetry. Now remember, the axis of symmetry has to cause a mirror image on both sides. Now the only place where I see 2 points right now is with the 2 and the 4, both at the x-intercept. So the mirror has to be right in between those. Now there's a couple of ways of finding that. One is just to count. There's 2 spaces there, so the mirror has to be 1 space away in the middle. But something that works for situations where you have bigger numbers is just take the 2 values, x-intercept 1 plus x-intercept 2, and then divide it by 2. Average the 2 numbers. You'll notice that in this case, 4 plus 2, because 4 is one intercept, 2 is the other one, divided by 2. 4 plus 2 divided by 2 is 6 divided by 2, which is 3. And so the axis of symmetry is going to be right here at x equals 3. Now, if that is the axis of symmetry, that then means that we can find the vertex, because remember, the vertex is on the axis of symmetry. So if the axis of symmetry is at x equals 3, we can now plug that in and solve. So let's go vertex, which is at x equals 3. So we'll plug 3 in. Y equals 3 squared minus 6 times 3 plus 8. So that's going to be 9 minus 18 plus 8. 9 minus 18 is negative 9 plus 8 is negative 1. So y equals negative 1. So the point will be right here at 3, negative 1. And so then we've got that. With the axis of symmetry, we can also reflect the y-intercept. So it's 3 spaces over. So let's put it 1, 2, 3 spaces the other way. So the x value there is 6. The y value is still 8. I now have 5 points. I can finish up the graph, and you can see very nicely that it ends up looking something like this. All right, you're welcome to put in a couple extra points if you want, but for me, that is good enough. All right, so now let's see if we can scroll down just a little bit, and then we will move along. So here's question number 2. We've got y equals x squared minus 4. So let's try this one out. So again, we're going to start with the y-intercept. The y-intercept is when x equals 0. And so we'll put y equals 0 squared minus 4. So y equals negative 4. So let's put that point on. There's my y-intercept. Let's go on and get the x-intercepts now. The x-intercepts, of course, is where y equals 0. Oh yeah, let me label this point. So 0, negative 4. All right, so y equals 0. So we'll go 0 equals x squared minus 4. And hopefully you recognize this as being the difference of squares. So x squared minus 4. The 4 is 2 squared. The x squared is x squared. So we'll go x plus 2, x minus 2, which means x plus 2 equals 0, or x minus 2 equals 0. If you're having a hard time with this part, then please go back and review how to factor. That's in some of the other videos that we've done. That was our last unit. So we've got x is negative 2 and x equals 2 when y is 0. So that's going to give me my two x-intercepts right here. So 2, 0 and negative 2, 0. So I've labeled those 2 points. From this point, we should get a good idea of what's going on. It's going down here. There's my y-intercept, and then up. Now we talked about before the axis of symmetry. The axis of symmetry should go right in between those x-intercepts. So right in between would actually be the y-axis in this situation, and you'll notice that the y-intercept is actually right on top of your axis of symmetry. So the axis of symmetry is at x equals 0, so we're labeling that. And then from this point, we just need a couple more points. We've used x-intercept, we've used y-intercept, so we're just going to finish up and pick another point. I'm going to choose a point that looks like it's going to be easy for me to get. Maybe x equals 1, maybe x equals 3, but, you know, kind of do a table for that. And so I'm going to choose just for the heck of it, x equals 1, because that'll give me something in between here. So I'll put 1 in for x, so I'll go y equals 1 squared minus 4. 1 squared is 1, minus 4 is negative 3. So when x is 1, y is negative 3. So I should be able to put that on my graph now. So I'll go 1, negative 3, as stated right here, and I can reflect that across the axis of symmetry. 1 space away, 1 space away, so that x value is now negative 1, comma, negative 3. And so there we go, we can finish it up. Just like this. Nice curve. And there you go. All right, so let's go ahead. We will do one more. So let's go down. All right, so last one for today. So same as always, we're going to be graphing the quadratic. Same points. So let's go with the y-intercept when x equals 0. So y equals negative 2 times 0 squared plus 4 times 0 minus 2. You work that out, you get y equals negative 2. So we'll put that down. So that is 0, negative 2. Then we'll go for the x-intercepts. The x-intercepts is when y equals 0. So we'll go 0 equals negative 2x squared plus 4x minus 2. So here we're going to factor. Now the first thing we should do whenever we factor is look for the greatest common factor. So negative 2 times x squared minus 2x plus 1, it looks like. And so 0 equals negative 2. Now, if we can factor this, that would be awfully nice. So I've got x and x. I've got to get a positive 1. So negative 1 and negative 1, which then add together to give me the negative 2. So we've got it factored. So either x minus 1 equals 0 or x minus 1. Oh, that's the same thing, isn't it? So we add 1. I did ignore the negative 2 right here. The reason is because negative 2 can't equal 0. If it was an x, then yes, I would worry about it. But the fact is negative 2 equals 0 doesn't make any sense. So we end up with an x equals 1. Now, since I only ended up with one x-intercept, then that means that that will also be my vertex, right? We talked about in class how if we have a curve either this way or that way or whatever it is, it can't cross through that line because if it curves and comes back, then there would be a second intercept. Same thing if it was going down and curved up that way. So that means that this has to be the axis of symmetry. So we're going to draw our axis of symmetry right there at x equals 1. So x equals 1 is my axis of symmetry. The vertex, of course, is at x equals 1 then, and so we'll plug in 1 into our equation, so y equals negative 2 times 1 squared. Oh wait, we already know what the vertex is. Okay, well that would have been interesting. I would have just got 0 out. So I've got that. I've got a point here which I can reflect across. So let's reflect that point across the y-axis. So that's now going to be at 2 comma negative 2, right? A space away, space away. Now I need to plug in another point. I don't have anything in between this time, so let's just plug in the next point. So 1, 2, 3 looks like it's probably going to be a fairly easy number. So let's go y equals, this is just the same as if I were putting it into a table. I'm not going to draw the official table because really I'm only getting 1 point here. So y equals negative 2 times 9 plus 12 minus 2. So negative 18 plus 12 minus 2. Negative 18 plus 12 is negative 6 minus 2 is negative 8. So when x was 3, y was negative 8. So 3 comma negative 8. So we'll go to 3, negative 8, and that is 2 spaces away, so I need to go 2 spaces away on the other side. So I've got 3, negative 8, and I've got negative 1, negative 8. There we go, we can draw the picture. Now I hope you notice a couple of things on this one. Number one, this is our first example of one that is what we call concave down, an upside down U. Okay, that is because of the negative in front. And then this is also a little bit skinnier than the previous ones that we did. Compare it to the ones that you did up on the first 2 questions. This one's a little bit skinnier. That's because of the 2 that's in front of the x squared. We'll talk about that more at a later time, but it's still good to recognize these things as they go. So that's the end of question number 3. See you tomorrow.